Next topic to discuss is hash or hashing. Hash function is a kind of algorithm that we run on piece of data, and the produce value, the output value is called checksum, digest, message digest, or hash value. So basically hash is a string value or a number which is the result of calculation of hashing algorithm. So it means we generate this hash value or string value or number from the text, from the data and information. Hashing is a one-way function that scrambles plain text to produce unique message digest. So keep in mind this is one-way function, and there is no way to reverse the hashing procedure to reveal the original data or messages. Keep in mind it's not reversible, neither we need to reverse them, because we use hash for integrity, for authentication purpose. We don't need to reverse them to reveal the data, no. So it is impossible to reverse or decrypt to get the real source or information if you have a hash value. Also, hash value is different for each and every file and data and information when it's generated. Even if you change a single dot, the hash value will be different. We use mainly to protect the integrity of data and information. This is the main purpose of hash, so that nobody can change the data. When you send the data from one location to another, so you send the hash value as well, so that the receiver can compare the hash value. So we use hash to protect against potential alter and change the bits. It means sender send the data and digest, either checksum or message digest or hash value. Receiver take the data and run an own hash value to create the digest. So what the receiver will do? Receiver then compare the digest. If the two digests are the same, then the data are not manipulated. It means nobody alter the data, nobody change the data. There are two commonly used methods. One is called MD5, other one is called SHA. I will show you in the lab, but however, just to discuss hash. So this is your data, your plain text, your information, your data. So you apply the hashing algorithm, either MD5 or SHA, and it will generate a hash text or value or number. And then you send this hash value to the receiver. They will compare. They will also generate the hash when they receive the data, and then they will compare. If it is the same, it means nobody changed the data. Now coming to two methods of hashing. One is called MD5. MD5 means message digest algorithm 5. There was a hashing algorithm MD5 1, 2, 3, 4 and 5. That's why it's 5. Message digest 5, and you can see here message digest 4 as well, which is not widely used, but however it's there because it's weak. Even MD5 is not recommended. You need to use the second one, which is SHA, but however you can still use them. MD5 message digest, it is also a hashing algorithm, and it will express each and everything in 32 digits hexadecimal number. It means whenever you have something and you generate the hash MD5, it will always generate 32 bit. It means 128 bit. Sorry, 32 digits. So when you count this, it will be 32 digits. So whatever, even if I give them a simple 1, 2, 3 and generate, either I give them a complete file, a huge file. Suppose if I go to desktop and give them a complete, if I have a text file, suppose this one Kali, and if I calculate again, it will be 32 digits, the hash value, and it means it will be 128 bit output all the time. Even if you give them 20 pages to generate the hash, either 20,000 pages, the output will be the same hash value, which is 128 bit hash value. So it means input data can be any size or any length, but the output size is always fixed, which is 128. And I show you here, I give them a ABC, the output was 32 digit, sorry, hexadecimal, either 128 bit, and I give them a long text file, same output. Same output means in the sense the length, it is always fixed. I did not say that this value will be the same. It will be different for each and everything. So the hash value is unique for every file, whatever the size and the type is. So even if I type here ABC, so the output is ending with 72, and if I give them 5 and generate, it will be different. Now 35 is the end, so the value will be different all the time, irrespective of size and type. And it is widely used in VPN and many other, even though you can use this MD5 for password, to store the password, and it was initially developed to store one-way hash of password as well. So we can use MD5 for integrity. Even if you try to download any file from Cisco, they will give you MD5 and SHA to verify the file. It is not only for file, it can be software as well. Even the shortcut as well, they have MD5 value. And even if you Microsoft Teams, so it will generate hash for this one as well. It doesn't mean that this hashing is only for file and information. Even for software, if I go to Cisco software download, not only Cisco, any vendor, when you go there and when you try to download anything, so they will give you a hash value to check the integrity, that whatever you download, it is the exact you download or not. Suppose if I go to any connect, and if you click here you may see two things. MD5 checksum, I told you it's called checksum as well, and this is the checksum. So if I try to download this any connect, and after the download and I want to verify, so I can open this any connect, such as like a hash calculator, and then I will copy this and put here. So if it is the same, it means the file I downloaded is the original one. It means I properly download. So you can use hash for this purpose as well, to check the integrity is not being altered, not being changed, and is properly download. So now you get the idea about MD5. Second one is SHA. SHA stands for Secure Hash Algorithm. This is also hashing algorithm which is used for integrity, to nobody change the data and nobody alter the data and nobody modify the data. And it can be information, it can be a software, it can be anything. You can use SHA for that purpose as well. So if I go there, so you may see SHA-521 checksum is also there. because SHA is in different flavor. There is SHA-1 which produce 160 bit. There is SHA-2 which produce 224 bit output. And there is a SHA-224, SHA-256, SHA-384, SHA-512. And if I go there in this hash calculator, so you may see if I want this one as well and calculate. So you can see the value become large. Even the file is ABC. MD5 will always produce 128 bit, while SHA-1 will produce how much? 160 bit. So this is 160 bit. And SHA-256 will produce 256 bit. So this is a bit longer. Similarly, SHA-384 is more big value, and similarly SHA-512 is a huge value. Even the data is ABC5, but SHA will give you different output. SHA-256 will give you different. 384 and 512. It's all about the output value. So these are the different flavor of SHA, and you may see widely use this one for integrity. Now let me show you here. So if I go there and I can give him a file, suppose Ahmad, and I want MD5, MD4, SHA, these one, leave it MD4 and calculator. So calculate. So you can see Ahmad, the output hash value is this one, which you can compare. Either let me give you example by another way. Suppose if I go and create a new text file ABC, and here I type ABC, either Ahmad, Ali, and I type dot and save. So now I want to send this ABC file to my friend. So before sending the file, I will generate hash value of this one, ABC. So the hash value is this one. Let me copy the hash value. This is the hash value of ABC text file. So when the receiver, my friend, receive ABC, what they will do, they will also use WinMD5 and they will generate the hash as well. And I will send them this hash through WhatsApp. What they will do, they will paste here and verify. So if it is match, original was this one and current is this one, it means it's match. So nobody changed this file on the way. If you change a small thing, I remove the dot and save. Now my friend, when he generate the hash and the hash I give them, let's paste this one and verify. So we say not match. It means somebody changed the data. With one small dot, you can see the whole hash is changed. Let me show you this one. When small thing you generate, it will. So what was Ahmad Ali dot? This was Ahmad, the original data, and play. So this is the hash value. Let's remove dot and you may see the changes. Look at the one which is highlighted. Almost 60% things are changed with one dot, and look at it's changing. One another dot, look at. So one small dot can change the entire hash value, and that's why the results say that it's not match, because when I sent the file it was Ahmad Ali dot, and when he received the data, so somebody in the way changed the dot, and that's why it's not match. So we are using this hash value for integrity, for checking, so that nobody changed the data. So you get the idea why we are using hashing, and this hashing can be used in VPN as well for integrity. So we verify this one. Now coming to another concept related to hashing is HMAC. First one is MAC, suppose message authentication code. Now there is another concept to use hashing for authentication as well. The first step is for integrity. Integrity means that nobody changed the data, nobody modify the data, nobody alter the data. But if you want authentication as well, then you can use HMAC, hash message authentication code. It means with HMAC you will need a secret key as well. So both parties, sender and receiver, will know the key as well. So Ahmed data, so is generate this hash value. Let me copy this new hash value. But there is a HMAC as well, and HMAC means hash message authentication, means there is authentication involved as well. So if I say HMAC and the password is 123456 suppose, and if I calculate, now the hash is different. Without password the hash was, where I copy, I think so it was this, let me do it again, without hash, so 12, I don't know what was one, yeah, this one. So this is the without password. Now I want to do HMAC for authentication as well. So this is the password and this is the data, and calculate. And now let's see, there is a difference between hash, definitely there will be, because there is a original data plus the password as well. Now both the sender and receiver will know the key, and key is 123456, and they have to use in sequence, means plus key plus the HMAC. It means key plus the hash value, then it will generate the same hash. Now this type of hash provide you two things, integrity as well and authentication. You may see how authenticate, means they will authenticate the receiver. They will ask the receiver that beside to generate the hash, put the key as well. Then it means you are the right person. So for that purpose we are using HMAC as well. And there is SHA as well. So this is SHA. It is more stronger, and you can use many flavor of SHA. There is SHA-1, SHA-2, SHA-3, and so many I told you. These are SHA-1, SHA-2, SHA-224, SHA-256, SHA-384, and SHA-512. You can use them. So this is the concept, and these concept can be used in SSL, and these concept can be used in VPN, and this concept will be used in IPsec. So you have the idea now that what is hashing and why we need this one. So we need basically for two things, for integrity and authentication. Authentication, if you are using HMAC or MAC, MAC means message authentication code, there is a hash plus the key as well. So it will identify the receiver that do you have the key. If you have the exit key, then it means you are the right person. So this prevent man in the middle attack, and it will create a difficult and a new hash. So it's better to use HMAC rather than hash, simple hash. And this is the way. So this is a sender, and they send something, so they will generate the hash value. Suppose they want to pay $100 to Bob. So this is the hashing algorithm, and this is the way they will send them. Bob will also generate the hash, and they will compare them. And when they compare the both the hash, if it is the same, it means they receive the correct amount. It means nobody changed the data. But however, now in this case, this is HMAC. They use a secret key as well. So hashing algorithm plus the secret key, it generates the value, and when the receiver receive the money, they also generate the hash plus the key. Both know the secret key, so they combine and generate the hash. So HMAC verified, and it means nobody changed the data when it was going through the internet. So HMAC is more secure rather than the simple hash. But however, we can use both for integrity and authentication. So I hope so you get the idea why we need hash and why we are using them.